This lesson will describe how to predict the products of single replacement reactions. Recall that a single replacement reaction shows an element and a compound as reactants. If a single replacement reaction occurs, it produces a new element and a different compound, however made from the same atoms or ions originally present as reactants. Chemical reactions are very much about stability of chemicals. Therefore, when particles rearrange, they seek to rearrange in the most stable format possible. Before predicting if a single replacement reaction can occur, we need to consult a chart called the activity series data. Activity series describes more reactive elements in comparison to less reactive ones. During single replacement, if an element is more reactive than a similar element that it would like to try to replace, then a reaction occurs. Counter if it is less reactive than the element it would like to replace. No reaction occurs. In this example, the element magnesium would like to try to replace the element aluminum, the similar element, also a metal. Magnesium can only replace aluminum if it is more reactive than aluminum. The activity series chart tells us the reactivity of elements in comparison. The chart that we will consult is a list of metals. First, you should locate the element that is trying to do the replacing. In this case, we can see the element magnesium is the element by itself. Therefore, magnesium is trying to replace aluminum. Always look for the element that is by itself on the reactant side before proceeding. When looking at the activity series data, we can see that magnesium is placed in a position above aluminum. This indicates that aluminum is less reactive, or that magnesium is more reactive than aluminum. When a metal is more reactive than another metal, it can cause single replacement reactions to occur. Therefore, magnesium will replace aluminum and become part of the compound, and aluminum will become the element. Writing the products for an element is simple. We simply use the periodic table for most elements. Aluminum symbols simply written as Al. Aluminum will be forming what we know as the element, which is a solid. When magnesium replaces aluminum, it forms an ionic compound made of both the magnesium ion with a 2+ charge and the chloride ion with a 1- charge. The formula for magnesium chloride would require 2 chloride ions to balance out against the 1 magnesium ion. Therefore, the symbols MgCl2 describe the compound. Since aluminum assumed the solid state, the magnesium chloride now assumes the aqueous state. Therefore, these would be the products: aluminum with magnesium chloride. You have predicted the products of an example for a single replacement reaction. Let's look at another example. Again, the key is to locate the element that is by itself before consulting the activity series chart. In this case, copper is the element by itself. Therefore, copper is the element trying to do the replacement. Copper would like to try to replace iron, but can only do so if it's more reactive than iron. When looking at the activity series data, we can see that copper is written below the position for iron, which means copper is less reactive than iron and cannot replace iron in a chemical reaction known as single replacement. Predicting the products for this series of reactants is then not necessary because no reaction would occur. Typically, we would write Nr representing no reaction. Copper is not reactive enough to replace iron. Looking at this example, we can see that calcium is now the element by itself. Therefore, calcium would like to try to replace the element sodium, but can only do so if it's more reactive. When consulting the activity series chart, we can see that calcium is located above sodium, indicating calcium is more reactive than sodium. We can therefore assume a single replacement reaction should occur. Knowing this, we realize that sodium will be the element isolated by itself as a product, and calcium will join up with the PO4 or the phosphate ion. To predict the correct formula for calcium phosphate, we need to consult the charges for each of the ions. Calcium always has a 2+ charge, with phosphate always having a 3- charge. With this in mind, the correct formula for calcium phosphate would require 3 calcium and 2 phosphate ions. The ion charges really are not part of the chemical reaction, but they help us predict the product, calcium phosphate in this case. Some special cases to look out for would involve hydrogen. Hydrogen can be replaced just like a metal in many single replacement reactions. However, we must more carefully consult the activity series chart when dealing with hydrogen. When looking at the activity series chart for hydrogen, we notice its position somewhere near the center of the chart. However, there's some very specific detail to pay careful attention to. Hydrogen can be found both in the compound known as water, or hydrogen can be found in what we know as an acid. When hydrogen is found in water, there are very few elements that can replace the hydrogen in water. The very top portion of the activity series chart shows which elements can replace the hydrogen in water. They range from lithium down to sodium. Since iron is not in that range from lithium down to sodium, iron cannot replace the hydrogen in water. Therefore, we write no reaction. However, the element calcium is in that position where it can replace the hydrogen found in water. Therefore, single replacement reaction will occur. When hydrogen is replaced, it will become the element by itself. Recall, there are 7 elements. We tend to call them the genuine elements in class. The elements ending in gen or ine tend to form what we know as diatomic molecules and must be written as such. The water ionizes, turning into the H and OH ions. H creates what we know as the hydrogen, or the H2, and the OH ion, or hydroxide ion, combines with the calcium ion. To write the correct formula for that product, you need to consult the charges of each ion. Calcium is a 2+ charge, with hydroxide being a 1- charge. To write the formula for calcium hydroxide, we would need 1 calcium ion, but 2 hydroxide ions. When water reacts in single replacement reaction, break the water into the H and OH ions, and always combine the hydroxide or OH ion with the single element, in this case calcium. Let us erase some of the work that allowed us to achieve the prediction. In the following examples below, hydrogen is found, but not in water. Hydrogen is found in an acid. Again, we must consult the activity series data before determining if hydrogen can be replaced. Locate the element by itself. In the first example, copper is by itself. Therefore, copper would like to try to replace the hydrogen found in the acid. The position of copper in the activity series data is too low to replace hydrogen. You can see hydrogen is written above copper. Therefore, copper is not reactive enough to replace hydrogen. So we will simply write Nr for no reaction in this case. Now we must consult the chart for magnesium ion, comparing magnesium ion to hydrogen. The position of magnesium is well above hydrogen. Therefore, magnesium can replace hydrogen in single replacement. This means hydrogen will be the element by itself on the product side. recall that hydrogen must be written as H2. The other product will be the combination of magnesium with a 2+ charge and chloride with a 1- charge. As these ions collide, they form the ionic compound known as magnesium chloride, requiring 1 magnesium and 2 chloride ions to form. The products of the reaction are now written. Hydrogen and magnesium chloride would form from this reaction. Learning how to read the activity series chart is the key to success for single replacement reactions. This chart tells us which elements are more reactive than other elements. Specifically, in this case, this is a list of metals. Single replacement can also happen for the elements known as the halogens. When a halogen is trying to be replaced, we simply use the periodic table as if it were activity series, comparing one halogen to the other. The halogens are simply the elements fluorine, chlorine, bromine, iodine. It takes some practice, but with a little time, single replacement reactions can be predicted fairly reliably using activity series data.